Welcome back to the shop. Today we're going to have a little bit of a change of gear. Going back to my roots, we're going to do some 3D printer modifications. This is one of two machines that I own, and I've been using them to do production work mostly. And mostly I've been using PLA Plus, which the stock HotEnd does just fine. These machines have over 1,000 hours on them each. They've been doing well for me, but I want to start printing a little bit more exotic filaments like PETG, which is supposedly has all the benefits of I should say all the benefits of PLA as well as all the benefits of ABS. I used to print in ABS exclusively in the past with my own home-built printer. If you guys have been watching the channel, you know I built my own machine, and that machine's long been retired. It's worn out and not worth rebuilding. But with that said, this machine, one of the two machines I'm going to turn into basically an exotic filament machine. And to do that, I'm going to replace the HotEnd in here with basically something that doesn't have a PTFE tube touching the nozzle. And the problem with that is these HotEnds are very small, and there's two solutions to that. I can either go for an aftermarket HotEnd that's bigger, and I have to come up with an adapter and so on and so forth, or I can go with the same form factor, but I have to upgrade the cooling. So I've decided to go the other route, and what I'm doing is I'm putting in these small 40 by 40 by 20 millimeter fans. Yes, they do sound like jet turbines. I don't really care. It's a machine that runs in a box, so it doesn't matter much to me as long as these fans are decently built. I'm okay with it. The other thing is that I noticed, even though I've upgraded the extruder on these to a metal extruder, because frankly speaking, the plastic extruder that these machines come with, complete and utter trash. If you get 50 hours of print time, I'm surprised, because on mine, both of them, the handle broke within like half a roll of filament. It was done. But even these, they kind of slip, right? So the brass hobbed gear, I'm not sure why they went that route, but it was just an easy upgrade to do this. But with that said, I'm going with a double geared extruder. This thing actually has basically a gear and two hobs that kind of pull the filament in. It's supposed to be a lot stronger. We'll see. I do see a few deficiencies in the design already. I'm not quite thrilled with the design, but with that said, I think it should be a pretty fair upgrade for a machine that's basically low cost as this. And before I start doing any of this, first thing I'm going to do is I'm going to clean these machines up, because they have a lot of dust on them. And not because they've been sitting, it's because I've been using them for so long, and really they don't need a ton of maintenance, let's put it that way. It's just usually clean out the bed and off we go. Fairly reliable machines, although I've had to re-level them every once in a while. So you give and take with that aspect. So before we start any of that, I'm just going to blow these things out, and I'm going to lube up the the compressor is almost out of air. I'm going to lube up this lead screw over here with ISO 68 oil. I've been using this on my milling machines and my lathes, and I really like it. And I've also been using it on these lead screws, and I think it's actually wonderful stuff. And I will show you what it looks like. If you guys want to pick up a tube, links in the description. Helps the channel out by a couple of pennies if you're looking to buy lubricant oil anyway. This thing is really good at lubricating these parts. It's basically it's sticky oil, like it's almost whey oil. I've been using it as whey oil on my machines, and as you can tell, I'm actually backfeeding the screw. It's a good way to go about it. So now let's start with the extruder upgrade, and then we're going to tackle the hot end. Be back. Alright, so this is the extruder here. This was also an upgrade, and it served me fairly well, but I think it's time for a better extruder. It seems to skip at certain speeds, and I think you can use a bit more torque, which the geared extruder will give it, because the actual hob is smaller, so you get a little bit more leverage that way. And let's see how this works. The extruder's out. Time to clean out some of this crap, and as you can see, I've actually worn a groove on the brass hob gear. Interesting. It's quite a few hours of print time on this thing. That hob gear goes away. The new hob gears are steel. So now it's time to prepare the new extruder. Here's one of the things that I actually don't like about this. Yes, there's ball bearings inside of this, but they're riding on a threaded bolt basically, and there's too much play in this. This is going to end up actually eating either up here or down here, more likely down here. It's going to end up eating the aluminum. If it does, I'll just machine it off, and if I need to, I'll make a new one of these with a press-in 3mm rod, so it'll actually center it properly. But for now, let's see how it works. This is the extruder body. So the first thing that goes into this, I guess, is the Bowden coupler. I'll give it a snug, you don't need to go gorilla on it. I always point the motor up this way, and so this way it doesn't really interfere. The extruder comes with basically all the fixings you need: screws, nuts, bolts, everything. So the first one is the chamfered screw that goes in the corner over here. That'll be the first one to get tightened. Alrighty. Okay. Let's not go overboard tightening these up, because there is some slop in this machining. I'll come back at the end and actually tighten everything down. Now it's time to put on the arm to make sure that this bolt is not going to back out too small. Alright, you don't need to go gorilla tight and actually pinch the thing down. It does come with a sleeve that the screw goes into. Just to give myself somewhat of a fighting chance, I am going to put a couple of drops of oil on this sleeve. Actually, before I do that, I probably want to insert this thing in there. See, this is what happens when you rush. I need to loosen up the extruder body before I there we go. Dropped right in. Now we get to put this lever on. Okay, time to snug these up. Again, don't go crazy tightening these things up. These are small 3mm screws. You really don't want to snap one of these. It's a bad day. Okay. So now it's time to align the gears, and for this one it's difficult to get the camera in there, but and this is supposed to tighten against the flat on here. This is basically, the tops are supposed to be even. This I would go ahead and give it a slight cronk on. The reason for it is it's going against the flat there. It's steel on steel on steel. And now time to there's one screw, which I believe this is 4mm. Just stick it out just slightly. And this is another thing that I don't like. This is a sheet metal thread cert. Is it zoom? Is it focusing? Yeah. And this is used in the bottom of this as a cup. And what you're supposed to do is squeeze this thing in there. The spring is quite stiff. Let's back out the screw a little bit. As you can see, the screw bears down on that cup, and you can actually tension this thing as much as you want. I want to go all hog crazy on it. You can barely move it. For now, I'm going to leave it on the loosest setting, which is just basically half a turn. Let's remove this little and this should be functional like so. So that's the extruder. Now it's time to deal with the hot end. So now the hot end is in place. I haven't done the extrusion calibration yet. I will show you how to do that. And I already wired the thicker fan in, and I'm not the first one to do something like this. Somebody actually put this out on Thingiverse. I'll put the link in the description. You guys can download the same piece. It is printed out of PETG. It's a terrible print, but I think once the fan and I tuned this machine actually for PETG, I think I'll probably get better results, and I might just reprint this, but for now it will have to do. So yeah, the only changes that are really made from the design was I actually just drilled 4 holes, so I can just pass these screws in, and 3 screws all the way through, and just tighten this thing down. No big deal. So as a matter of fact, I'm gonna start tightening these down now. I wanted to show you guys the difference between the stock fan, this is the Creality fan, and what I put in there. Reminds me of the commercial. Wimpy, wimpy, wimpy. Hefty, hefty, hefty. And the reason for that is to allow the hot end to do its job, so we can actually run the temperatures up in the higher end of the scale without worrying about PTFE breaking down. So I know what you're all thinking. That thing's gonna sound like a jet turbine. And you know something? I think you're right. Alexa, turn on printer 2. it's actually not terrible. So I've set the hot end to heat up, and now what I'm going to do is I'm going to take this filament and I'm going to, using my flush cutters here, I'm going to cut it flush with fitting, and I'm going to take my Repetier server on my phone here, and I'm going to tell it to extrude 100 mil at 10 millimeters a second. I'm going to take this, and you know what? I'm just going to cut it and measure it out. This definitely does not look like 100 millimeters. Looks like about 66.34 millimeters. So let's check what the regular E-steps are on this thing. So I am running stock firmware on Marlin. I'm going to go to Control, Motion, steps per millimeter, E-steps per millimeter, which is 93. So we need to figure out, it thinks that 100 millimeters takes 93 steps per millimeter. It's only extruding out 66. So now we got to do the math. So what happened was we measured out 66 millimeters on this. The current steps per millimeter is 93. So the formula is very simple. It's 93 times 100 because we asked the printer to extrude 100 millimeters divided by 66. And it's pretty darn close to 141. So what we're going to do is we're going to go to Control, Motion, steps per millimeter, E-steps per millimeter, and we're going to go to 141 roughly. So we set this up at 141 E-steps per millimeter. Now let's click on Load Settings. Once we stored it, go to Motion and steps per millimeter. It should be the same. So hopefully now I can tell the printer to extrude another 100 millimeters, and we should get 100 millimeters. That brings us to the conclusion of this video. If you guys want to pick up the same products that I'm using, links are in the description. Helps the channel a little bit. I hope it helps somebody, and I'll see you next time. Bye.